Hello and welcome to the video. Today we're going to be looking at solving simultaneous equations. We'll be looking at two equations and two unknowns, and then I'm going to do another example with three equations and three unknowns. But let's start with the two equations, two unknowns case. So solve for x, y the following system of equations. 2x plus y equals 23. 3x minus 2y equals 3. Okay, so what you want to do is you want to try and eliminate one of the variables, and then that leaves one variable, and then you can solve for that one, and then you plug it back in to get the other one. So I always like to solve for x first. I want to find x first, so that means I have to eliminate y. So to eliminate y, we need to be able to add these equations together or subtract these equations. So the coefficient of y ideally would have to be the same or have the same parity. So we would need to have like a 2, 2 and 2, or 1 and 1. Okay, well, it's much easier to multiply than to divide. So to get them with the same coefficient, we will multiply by 2. So I'm going to label these equations just for convenience. So I'm going to call that 1 and call that 2. So equation 1 is 2x plus y equals 23. Equation 2 is 3x minus 2y equals 3. So now what I'm going to do is going to multiply equation 1 by 2. And that will give me 4x plus 2y equals 46. I'm going to call that 3. Now what we can do is we can add, because we've got a 2 before the y here on number 2 and 3 equation, we can add them together. So let's do that. So 7x minus 2 plus 2y is 0, so that's y eliminated, and that equals 49. And there you go. So we have x already. X is just 7. Okay, so we can call that 4. Still an equation, so I'll just give it a name for convenience. So now we plug that back into 1 or 2, doesn't really matter. So I'll plug it back into 1, so x equals 7, plug that into 1. So then we get 2 times 7 plus y equals 23. So then 14 plus y equals 23. So then y equals 9. And that's it. And now we have our answers. We've solved for x and y. So our solution set x, y equals 7, 9. And you can just go and check it. Plug 7 in for x and 9 in for y. So 2 times 7 is 16. Sorry, 2 times 7 is 14. Plus 9 is 23, so that checks out. 3 times 7 is 21, minus 2 times 9 is 18, so 21 minus 18 is 3. So that all checks out. So guys, this was the two equations, two unknowns case. We're now going to be looking at a 3 equation, 3 unknown case. But before I get into that, I just want to show you something. What you'll notice about these problems is, usually you're going to have the same number of equations as unknowns. So you need to have at least one equation for each unknown. If I only had one equation there, say that was all I had, and I was asked to solve that, I couldn't do it because I've got two variables or two unknowns with one equation. So there would be an infinite number of solutions. You could plug a given x in there, and then y is just 23 minus 2x. So x could be anything, so therefore y could be anything. So it's an infinite number of solutions. But once you introduce the second equation, that's it, it locks it down. So you're only going to get one answer. And the reason for that, another way to think about it, if you drew it on a graph, imagine you drew a graph. It's basically two straight lines. And what you're doing is, when you solve it simultaneously, you're finding the point of intersection. So that is the point of intersection, 7, 9, if you were to draw these on a graph. Okay, so now we're going to move over to the three unknown case. So now we're going to look at the three equations in three unknowns case, and now we've got an extra variable z, so we need to solve this system of equations for x, y and z. So x plus y plus z equals 6, 3x plus 2y minus z equals 4, 2x minus y plus 3z equals 9. So it's simultaneous equations, three equations and three unknowns. We're just going to do it the same way we did it for the two equations, two unknowns case. We apply the same principles. We just need to eliminate variables. So we're going to reduce it down to two equations and two unknowns involving x and y. And then from there we proceed like we did in the two unknowns case, and we can get x or we can get y. And then we just plug it back in and go from there. It's pretty straightforward after that. Okay, so I'm going to try and eliminate z first. So if I add 1 and 2 together, you can see that the z's will cancel. I've got a z and a minus z. So let's do that. So 1 plus 2 will give us 4x plus 3y equals 10. So I've got an equation involving x and y, but there's two unknowns, so I need another equation. So I need to eliminate z again. But I can't eliminate z from 1 and 2 because I've already done that. So I need to eliminate it from two of the other equations. So it's either going to be 2 and 3 or 1 and 3. So the easiest one looks to be number 1. If I multiply that by 3, that will give me 3z, and then I can subtract 1 and 3. I could divide 3 by 3, but then that's going to involve fractions. It's very messy. Multiplication is much easier. I strongly recommend you don't divide in these equations, solving these equations. Unless you've got very, very nice numbers, stay away from division. Stick to multiplication. So 1 times 3 will give us 3x plus 3y plus z equals, plus 3z equals 18. And then I will call that equation 5. And then I'm just going to subtract that from equation 3 to eliminate the 3z's to get x plus 4y equals 9. So now I've got two equations and two unknowns involving x and y. This is now a two equation, two unknown system like we did in the previous case. So we proceed like we did in that case. Okay, now I could eliminate y, but it's much easier to eliminate x here because it only involves one operation. So if I multiply equation 6 by 4, that will give me a 4x, and then I can subtract. So 4x plus 16y is 36. So I'm going to call that equation 7, and then if you see, we've got a 4x there and a 4x in equation 4, so just subtract them. 7 minus 4 is 13y is equal to 26. So y is equal to 2. I'm going to call that equation 8. So now I can plug in y equals 2 back into equation 6. So 8 into 6. Where's 6? 6 is x plus 4y equals 9. So I found y to be 2. So plug that in. I get x plus 4 times 2 equals 9. So x equals 1. Call that equation 9. So I found x and I found y. Okay, so we plug in equation 8 and 9 into 1, which was y equals 2 and x equals 1 into 1. And if you just go back, what was 1? It was x plus y plus z equals 6. Very simple equation. No complicated coefficients or anything like that. Okay, so plug them in. You get 1 plus 2 plus z equals 6. So z equals 3. Call it 10. You don't have to call it anything. You've now found all of your variables, x, y, and z. You've solved the system. So the solutions are x, y, z is equal to 1, 2, 3. So there you go, guys. And we can do that for 4 equations, 4 unknowns, 5 equations, 5 unknowns. We just apply the same principles as we did for the 2 and the 3 case. Okay, so thanks for watching the video, guys. I really appreciate you taking time to view my videos. Please like, share and subscribe, and I'll see you on the next video.